Hi students, now I am going to teach Biot Savart Law. So in the year of the 1819, the two scientists Biot and Savart did the experiment to explain the force experienced by the magnet. Then it is placed near to the current carrying conductor. And this law is also give the mathematical expression for the magnetic field produced by the current carrying conductor, that is the magnetic induction due to the infinitely long state current carrying conductor is also calculated by using the Biot Savart law. So according to the Biot Savart law, here the magnetic field at a point P at a distance r from the small elemental length of the conductor. Here we take this is one of the current carrying conductor, positive, negative. So this is a current carrying conductor. The current is I is passing through the conductor. So in the current carrying conductor, we take the small element. We take the point, the small element. It has a length is dl vector. So for the small element dl at a point P with the distance r, the magnetic induction due to the current carrying conductor at a point B is also calculated by using this Biot Savart law. So according to the Biot Savart law, here this magnetic field is making the angle is theta. According to this Biot Savart law, here that magnetic field at a point P at a distance r from the small elemental length is directly proportional to strength of the current. The strength of the current is noted letter I, and it is also directly proportional to magnitude of the length of the element. The length of the element is noted letter dl, and it is also directly proportional to the magnetic induction or the magnetic field due to the current carrying conductor at a point B at a distance r is also directly proportional to sine of the angle between elemental length dl and the distance r, and it is inversely proportional to square of the distance between the point P and the length element dl. So in the mathematical expression we can write that magnetic field, the magnitude of the magnetic field is directly proportional to the current, and it is also directly proportional to the magnitude of the length of the element dl, and it is also directly proportional to the sine of the angle. Angle means that is theta, angle between the dl and r, and it is inversely proportional to the distance between the point P and the elemental length dl. Here the point P from the elemental length it has a distance is r, so we can write that is r square. So dB is directly proportional to the ideal sin theta divided by r square. So from this we can write dB is equal means we want to give the constants, that is k and I dl sin theta divided by r square, where k is the constant of proportionality. It has the values mu naught divided by 4 pi. Here in SI units, k is equal to 1 in CGS unit. So here the values of the k is mu naught divided by 4 pi in SI unit, and k is equal to 1 in CGS unit. The value of the k is also given. So in vector notation, we can write the dB vector is equal to mu naught divided by 4 pi, that is the values of the k in SI unit, mu naught divided by 4 pi. dl is a vector quantity, dl into r cap divided by r square. Okay, here the magnitude is ideal divided by r square. That only we can write. The sin theta, it is indicated the direction. Here only it is indicated by the r cap, because here the dB vector is perpendicular to the both ideal. Is perpendicular to the both ideal means here we can write what is mean by theta. Theta is directly proportional to the sine of the angle between the dl and r. The dl and r, it has the angle, that is theta. The theta is perpendicular. Theta perpendicular means sine 90 degree is equal to 1. Okay, so only here the direction is indicated by the r cap. So from this dB vector, we can calculate the values of the total magnetic field at the point P. The total magnetic field is not a better B vector. The B vector means it is calculated by using integration of dB vector. So already you know the values of the dB vector. It is substituting this equation means we can write, that is integral of mu naught divided by 4 pi idl vector r cap divided by r square. So this is one of the net magnetic field at a point P due to the conductor. So now we are going to discuss about the special cases. Case 1, if the point P lies on the conductor. Lies on the conductor means what is the values of the theta? Theta is equal to 0 degree. Theta 0 degree means here it is substituting this to sin 0 is equal to 0. So what is the values of the magnetic field? The magnetic field dB vector is equal to 0. Case 2, if the point P perpendicular to the conductor. Perpendicular to the conductor means here the theta. The theta is perpendicular means theta is equal to 90 degree. That only we discussed. So theta is equal to 90 degree means sin 90 degree is equal to 1. So we can write what is the values of the dB vector. The dB vector is equal to mu naught divided by 4 pi idl vector r cap divided by r square. Okay students, here this law is also having the similarity with the Coulomb's law. So now we are going to discuss about the similarity between the Coulomb's law and the Biot Savart law. Here the Biot Savart law and the Coulomb's law both are obey the inverse square law. So they are long range field. Here the magnetic field and the electric field both are the long range field. Both are obey the inverse square law. So next one is, it is obey the principle of superposition and are linear with respect to the source. So in magnitude we can write that the electric field is also the electric field is depend upon the charge. Here the magnetic field is depend upon the ideal. Okay, from this we can write. Okay, it is obey the principle of superposition and they are linear, and it is also with respect to the source. It is respect to the source. So the electric field is always depend upon the, that is directly proportional to the charge. Here the magnetic field is also depend upon the current passing through the conductor and the elemental length dl. Okay, so only we can write B is directly proportional to the I into dl. These are the similarities between the Coulomb's law and the Biot Savart law. So next we are going to discuss about this, the difference between the Coulomb's law and the Biot Savart law. Students, now I am going to explain the differences between the electric field and the magnetic field, or Coulomb's law and the Biot Savart law. So here we know that here the Coulomb's law, it is also give that electric field due to the charge. So we know that it is produced by the scalar quantity. The electric field produced by a scalar quantity, that is charge, electric charge, that is notable letter Q. Here the Biot Savart law, it is explained for the magnetic field. So it is produced by the current element I into dl. We know that the I into dl is vector, so this is a vector quantity. So it is produced by the magnetic field, produced by a vector quantity, that is current element. Ideal vector. So next, here the electric field, it is directed along the position vector joining the source and the point which the field is calculated. Okay, we calculated for the axial line and we are calculated for the equatorial line. So it is directed, the electric field is directed along the position vector joining the source and the point which the field is calculated. For the magnetic field, it is directed perpendicular. It is directed perpendicular to the position vector or vector and the current element ideal vector. Okay students, so it is directed perpendicular to the position vector r vector and the source and the current element ideal vector. Here the electric field does not depend any angle, does not depend any angle, but we know that here this magnetic field is depends upon the angle between the position vector r and the current element ideal vector. Okay, so these are the differences between the electric field and the magnetic field or Coulomb's law and Biot Savart law.